Hello, everyone, and thank you for joining us. Today, we will be talking about large language models and how to build them with open source. I'm not alone. Together with me, I have Maciek Mazur. Maciek, would you like to introduce yourself?
Yeah, sure. Hello, welcome everyone, and thank you for listening. My name is Maciek Mazur, and I'm running our professional services teams responsible for data and AI.
Thank you, Maciek. I think for those who have been following us for a while, they are used to us. But for those who don't know me, I'm Andrea Montano. I'm the AI product manager at Canonical. So today we will be talking about large language models beyond ChatGPT and how to actually build them. We'll be cover how to implement or how to get started with large language models in your organizations, and last but not least, how to leverage open source. We have some interesting debates prepared. Should you build or should you use a large language models? So just stay tuned with us. For those who are not familiar, large language models refers to models that use deep learning techniques to capture complex patterns to produce text. They are usually trained using self-supervised learning, and beyond the scene, they are a large transformer model, which is too massive to run on a single machine. They're often provided as an API or as a web interface. But let's dig a bit deeper into it. They are large because they are trained on huge data sets and they have billions of parameters. I had to think twice because uh, I said once that they have millions of parameters, and Maciek told me that is not true. And maybe to give you a bit of a context, ChatGPT 3 has more than 175 billion parameters and was trained actually on more than 40 terabytes of text. They include the language part in the name because they operate primarily on human language. And then they are model as well, as you are already used to here, because they are used to find patterns with history. But the history of large language models, it doesn't start in 2022 when ChatGPT became famous. Even if I think that's when the generative AI story and the large language model as a technology exploded. So the initial attempts go back in the 50s. Not even Maciek was working back then. Uh, and they were attempting to use rules, logistical steps to accomplish tasks such as translations. The main challenge back then was the compute power, and this has been the challenge for quite some time, I'll have to say. But over time, they start evolving and they use language patterns and statistical models. In 2018, I think it's an important stepping stone when BERT is introduced. And in 2020, OpenAI releases their large language model at the time. From there on, it's history, and nowadays, I think we see plenty of LLMs coming up on the market. And I already said from the agenda that we should go beyond ChatGPT. As much as I love it, the truth is that LLMs have applications across all industry. They have grown in size, and so have their capabilities. They are broadly used for text-based content and can be divided in, I think, four main categories that apply in all industries. They are used for text generation, such as marketing content creation, for example. They are used for summarization, for meeting notes, for translation, text to code, for example, or between languages, classification, such as text analysis, and last but not least, chatbots. Here, actually, I'll go back to this point and say that whereas all the applications related to text-based applications are great, I would always encourage our audience to really read or to really check it out the results of the applications because it's very easy sometimes to blame, hey, it's ChatGPT fault, but at the same time, we as users have the responsibility to ensure that we get the result that we want. And when it comes to application or to benefits or to benefits compared to machine learning, it is worth mentioning that LLMs are specialized in NLP, and they're not designed to handle structured data, image analysis, or even clustering. There are other machine learning algorithms and models, such as the classical linear regression or convolutional neural networks, that would be more appropriate. Your choice of choosing LLMs or just choosing another algorithm should depend on your use case. And don't do it just because everyone on the market does it, because I think that's a bit of a trap that you might fall into and you might be disappointed because maybe it doesn't solve your real problem. However, LLMs do have a couple of benefits. They have shown a significant improvements in performance across a wide range of NLP tasks, often surpassing previous state-of-the-art models, and sometimes approaching human-level performance. To be honest, I never thought that could be possible a couple of years back, but it is exciting. But then also LLMs can demonstrate ability to learn new tasks with limited or no additional training, which really translates into time efficiency and cost savings as well for organizations. And last but not least, there is a benefit related to the ability to handle multitasks as well as support multiple languages. I think especially for those who are not English speakers, that is very exciting. And build versus use. There are plenty of large language models nowadays on the market, yet sometimes we do have customers who consider building their own. Maciek, what do you think? Should we build the LLM or use existing ones?
If you have to ask this question, most probably you should use a foundational model which was already built and pre-trained, because creating a new large language model requires a huge infrastructure. It's a really big investment, and basically you are redoing a lot of stuff from scratch that people already did, because the large language model needs to first be trained on like basic corpuses of text to understand written messages, to be able to translate text to vectors and do a lot of basic things, right? And the training process of a large language model is very also long, and it's much faster in order to look for like time to market or potential ROI fast. It's much easier to use a foundational model, but obviously the foundational model will not solve all of your problems, because this is just a model that understands text and you can ask questions to or chat with. But in reality, you need to learn it how to be specific to your business with either fine-tuning, playing with prompts, detuning, different methods, RAG. So we'll talk about all of them later on, but basically using a foundational model properly tuned to your business is usually the answer.
This is quite a nice sneak peek on what's coming next. But at the same time, I do think it's important to emphasize the challenges that organizations especially have when it comes to building their own large language models. On one hand, you have, or it's likely to have challenges when it comes to compute power, but also on the other hand, having enough data to train such a model, I don't think that it is really handy for everyone. However, even if you use an LLM, don't just use one and expect the best results, but rather think on how to optimize it. And I won't make it any longer now. I should give it to Maciek because he has the right tools and knowledge to tell us how to actually optimize LLMs for our use case. Maciek, what do we have in this picture?
Yeah, so this is the most basic architecture, how you can start playing with large language models utilizing your own data set, either if you are a researcher and you have some documents in your research institute, like papers and that kind of stuff that you want to summarize or ask questions about, or you're a business and you just have a knowledge base of like 10 years of running something, or even if you are non-IT business and want to enroll your new employees faster and you want them to know more stuff about the company. In all of those use cases, you probably start with some knowledge base. It might not be that nice in terms of this is not a ready-made database with knowledge graphs. It might be a bunch of text files in some shared drive, or documents from Microsoft Office kind of tools, or PDFs and that kind of thing. So first thing that you need to do is to extract basic text out of it. So what we are doing, we are extracting and splitting that into chunks and utilizing a thing called embeddings model to actually translate those chunks into vectors. Because the trick about LLMs is that they don't actually understand languages. Like Andrea mentioned that they are multilingual. They are actually just mathematical things that operates on vectors and numbers. So we need to, and for them, like the language doesn't really matter. So that's why we need to first use an embeddings model and prepare this data to be stored. Obviously, in order to use them efficiently, we cannot just store them as like flat files with vectors. We are using a thing called a vector database, and typical open source example of it would be OpenSearch. And that makes our setup ready to start asking questions. So whenever a new user comes to a UI or an application and asks a query, the same embeddings model is used to translate their query into vectors so that you can ask a question in any language you want, basically, because it will end up being very similar vectors in the end. And what happens later on, in order to enhance the foundational large language model like Facebook's Llama with your internal knowledge, the system will perform something called similarity search. There are different ways how to do it, but basically what it means, it's trying to look in the chunks of data that are vectorized of something that matches your question. So for example, if you ask questions about like sales targets for this year and you have some documentation about it, the chunks which have vectors around sales, around targets, around numbers or compensation or any kind of similar words that you might find in a dictionary, they will be extracted and then added to the prompt. So we are manipulating the prompt and the LLM is not being asked a question like, hey, what are the sales targets for my team for next year? But hey, what are the sales targets for my team for next year in the context of these chunks of data? And obviously it fetches the right pieces of the documentation, and it's super easy for a large language model then to generate an answer based on that, because it actually gets much more enriched and better questions. So that's a super basic setup. That's not how we are implementing it in production in the real world.
I
And
do
if you
have a
can,
question here,
yeah,
Maciek, before we jump to the next slide. Is this the kind of setup that someone who's just getting started with large language models or someone who's very enthusiastic should look at more in depth? Is this good enough for a beginner?
yes, sure. That's completely good enough to start testing it out, because you can fetch the LLM from Hugging Faces. You can deploy all of this on a simple VM in a public cloud or a powerful enough laptop with the GPU. OpenSearch is free to use. You can get it and install very quickly. Just like Juju deploy OpenSearch and that's it. So that's something that will help you out to get some feeling of how open source language models look like, how good they are, evaluate if the answers are nice. And yeah, that's a very good like experimentation kind of setup.
What about this one?
Yeah, this one is more of the real world. So as you can see on the bottom left of that picture, you have the thing called ingestion pipeline. So basically, in reality, it's not like a single PDF that we will take and want to large language model to be able to answer about. In real businesses, you have tons of data, and there will be tons of different pipelines trying to translate them correctly into a textual format. There might be some data which are like charts or images, and you need to use different ML models to actually extract what is on the image into text so that you can feed it into your vector store. And all of this is handled typically by Kubeflow pipelines. That's like an automation engine for your MLOps. And it allows you to do all this like data preprocessing, putting it into chunks and basically storing embeddings. And for that, you can use multiple pipelines that will extract data from multiple different departments, databases, types of data that you have in your company. Another difference in that picture is obviously that whenever you ask a query, it's in a context. So you have the history of all the questions that particular user was asking, and you augment their question immediately by the context of previous conversations, because the question might be, hey, I asked yesterday about the sales numbers and you give me an answer, but the person XYZ changed them today. What is the new one? Or something like that, right? So before you are able to answer this kind of questions, you need the historical context. Additional difference here is basically the usage of something which I would call the EDD. That's basically evaluation driven development. So whenever you get an answer, the actual end answer from the LLM, you are trying to evaluate how good it is in order to tune different parameters and the setup of this process. This is also happening with Kubeflow pipeline, but you are also storing the models that you find are working better, the fine-tuned models that the fine-tuning results are nicer in MLflow. And basically, in that setup, you are trying to evaluate for a couple of different things. This is an extension of a typical RAG pipeline where you can evaluate, for example, for faithfulness. So basically, you measure if the response for your query matches any of the sources. But you can also try to look for relevancy and measure if the response and the source are actually matching the query. So that depending on what type of an LLM system you're building and how you want your questions to be, like, do you want them relevant or 100% correct, or do you want embedding similarity between the answers to different users because you are targeting a big group of users that you want to do the same based on the output. There are different methods of how you can go there. And basically, this kind of setup is more resembling a production one. And actually, the most difficult part is not deploying a large language model or building up the RAG system and the vector store, because there is a lot of tooling that I see that you will be talking about later on that helps us to do that and automates this whole process, but actually extracting the right data. And whenever you're working with any kind of machine learning, the results typically depend on the quality of your data. That's the most important thing, and you should focus on your ingestion pipeline and actually populating your vector store with something that is relevant, high quality, not strange missing values, and then you will be getting good results. So the whole, I know that it's super fun to play with fine tuning and prompt tuning and do this whole fancy new stuff around LLMs that you can read up every day on Twitter, but basically you are getting much better ROI and much better business results by actually looking into your data sets and making them clean.
It's X nowadays, Maciek. I do have a question for you because you highlighted something interesting. Do I understand it correctly that LLMs fall into the same habit of you build a model, but then you need to continuously retrain it because otherwise it becomes outdated?
Well, you don't actually retrain it, right? So the foundational model is trained anyways, but you are doing either a lot of fine tuning or you are optimizing the process of how you do the RAG thing. So how do you extract actually data from vector store? Which do you extract? What is your similarity search algorithm? Is it KNN or something more sophisticated? And that kind of stuff. So you are not retraining the model itself, but you are changing the whole pipeline. And that's why we are using Kubeflow here, because this gives you a repeatability and automation, and you can still have the history of the old pipelines, go back to something that worked previously, so that you don't manipulate the code that runs with it without having it version controlled and so on.
Thank you. I'll move towards the idea of using open source. And in Canonical, the truth is that we do have open source in our DNA. That's what we think is the answer to everything. What do you want for lunch? Open source, probably. But the truth is, or going back, there are two angles to look at LLMs from the open source perspective. On one hand, you have the models that can be open source, and then you have the tools. And this is quite a new trend on the market on having open source models. I'm curious, Maciek, what do you think are the impacts of also open sourcing models? Because until now, most of the times you will have tools, but that's where it would stop.
Well, I think that the most important part around open sourcing the models is their environmental impact, because basically training a large language model with a size of what OpenAI is doing or what X is doing right now, or any other like bigger company, this is huge data center, a lot of electricity being used, carbon emissions and that kind of stuff. And if these models would be kept by every company to themselves, you will have all Fortune 500 companies building huge data centers and creating their own foundational models, which makes no sense, not only environmentally, but also economically, right? Because instead of sharing the cost of developing a basic model that can speak English that everyone needs, they would just create one by themselves. So I think that that's the main reason why open sourcing this large language models is super important for everyone.
I think, thank you, Maciek. I would also like to add that open sourcing them give access to everyone to try it out and upskill quite quickly when it comes to large language models. And I think if you look at the trends on the market, that everyone is looking for experts in LLMs, having actually models that you can play with is crucial. And then we will look at the open source tools that can help you, and Maciek already mentioned a couple of them. But let's look initially at large language models. Why should we use open source ones? Well, it's easy to get started, and I think that's the most important part nowadays when everyone is curious about them and would like to see how and if they could work. But then you also have cost efficiency. Maciek already mentioned the costs of building your own data center. And if you look at organizations, that would be expensive and also unsustainable. But also for people, I think that if you don't have open source LLMs, it would be quite difficult and quite expensive to try them out. But then you also have flexibility on them. On the other hand, there are a couple of concerns. Whereas you do have community support, you lack enterprise support if you use an open source LLM. And there are still questions regarding security and privacy. Last but not least, I think the learning curve when you use open source in general is a bit steeper, and it can be frustrating at times. Um, and now I'll move towards two famous LLMs models. I think the industry talks a lot about them. Maciek, which one do you prefer, Llama 2 or Langchain?
That's not really the correct question because Llama 2 is actually a large language model and LangChain is just a tool that helps us to do all of this pipelining and things around that I was showing on the picture. So LangChain, that's a bit misunderstood because it's a lot of times shown in the context of LLMs, but it's actually a framework that helps us to develop the whole application business use case, which is powered by an LLM. So LangChain gives us ability to quickly parse different types of files, CSVs, HTML, PDF, that kind of stuff. There are a lot of helpers. There are a lot of helpers to parse the output of an LLM, transforming documents, connecting to a vector store. So basically, it makes the job much easier. And I would rather say that this is very similar in that in software development, in web applications, we had tons of frameworks like Ruby had Ruby on Rails, PHP has their own bunch of frameworks, like in Python we have Django, and here in context of LLMs we have LangChain that will help us to build applications efficiently, quickly, and in a repeatable manner. That's the most important part.
So it means that you can use Llama 2 and Langchain together in the same application if needed.
So basically what LangChain gives is a capability to actually use tons of different LLMs and test out with them. So imagine that you have all of those pipelines that we have seen on the picture with built with LangChain, using Kubeflow and all this kind of stuff. And obviously there is a new large language model that is advertised as great every week. Like Mistral created their own, which is supposing to be really good, right? You want to test it out. You can, with one change in a one line of code, changing the address on the Hugging Face, and you pull the model via Git LFS instead of pulling the Llama 2, you are pulling Mistral, testing it out on your data, on your results and everything. So it's like super easy to swap between different LLMs and test them out. Also with their sizes, like Llama 2 is not actually one model. There is different amounts of parameters, different quantizations, and you can test between those because obviously the bigger the model and the more efficient it will be, but it will also require more GPUs from you. Sometimes the investment is not worth it. So there are trade-offs, and that's like, thanks to LangChain, we can very quickly iterate and experiment.
Now I have a question, Maciek. How do you choose the right LLM to use for your project? Because I think there is a lot of mystery around that.
I think it's a too new field to have a prescriptive answer that, hey, use cases A, B, C, you use this model, and D, E, F, the other model, especially that there is a, as I mentioned, new model released every week or every month, which is better than the previous one. So I think that in this kind of rapid development phase, it's very hard to prescribe things like that. I would rather just have the process automated enough with tools like LangChain, pipelines, and different kinds of automation so that you can very quickly, for example, run two tracks in parallel, perform A/B testing, and see what works best for your use case. It's much more efficient than trying to theorize about it and read thousands of papers and try to magically choose the right one.
Thank you. And are there a couple of LLMs that you could give as examples beyond Llama 2 that I think made the tour of the news?
Well, currently I'm mostly playing with Mistral and Palm, and especially in the context of Palm, the SecPalm model that Google released, which is like targeted for security professionals and is really good in understanding like bug fixes, vulnerabilities, and security of software, especially that we are an open source company and we are trying to be more efficient in securing all the packages that are there. What's also interesting is Falcon, even though it's pretty old, it's still getting improved by the research team behind it. And I think that sometimes it's more compute efficient than other options. So that's the ones that I would use. And obviously, like whatever you are building, it's nice to compare it with what OpenAI has, like have a ChatGPT subscription and see what kind of results you are getting. Last but not least, very influential in the open source space, that would be Vicuña model. This is basically something that is really good in a lot of niche use cases and requires a lower count of parameters versus like ChatGPT to answer the same questions on the same level. So it's also interesting to experiment with that. These are the ones that I'm playing around these days, but this answer might change next week. Right?
I was about to say that. What also raises to me as a question when it comes to LLMs is, don't they become outdated very quickly because of this hype on the market that every other week you have a new best LLM on the market? What happens with the old ones?
Well, not much, because it's not like that the model gets outdated. Imagine that if you, instead of training a model, you are training the person. You teach them from a toddler to speak English, to understand your business, and so on. So if there are new employees which are coming from like higher grade educational system, is the other one useless? I mean, the model is still there. It can do what it was supposed to do. And since we have enough automation, you can very quickly swap it to another one. So, I mean, I would rather say that if you have a working setup, it's much more efficient to do fine tuning and to play with the whole rack setup and different parameters to try to get better results, and don't over optimize, because it does not always make sense. You can focus on solving another business problem and bring better results to your organization, university, or company, or wherever you're doing that.
This raises me a question for our audience. Would you like to have a webinar on how to actually fine-tune an LLM and go deeper into details from that perspective? So in the comments, so we will know about it. And now I'll move towards open source tools. Again, they're easy to get started, and that's something that's very exciting. I just recorded a video on installing MLflow in less than 5 minutes, and it's very important to have tools that you can easily use, and then that you can also customize depending on your needs. I added here as an addition ability to contribute, and I think we should emphasize more the importance and the need to actually contribute to open source projects. Sometimes even if you share your feedback on, hey, I've been using Kubeflow pipelines for LLMs, and these are the challenges that I had, it's still a contribution, and the developers behind the project will benefit to better understand use cases, to better understand gaps that they have in their capabilities as well. And then if you are an enthusiast, you can always write code and have even more contributions. However, when there are a couple of drawbacks as well, the steeper learning curve still stays there, and I add documentation as well. I still wonder every now and then how we could fix the documentation challenge in the open source world, but that's a topic for another time. Bug fixes can take longer sometimes, and there is lack of enterprise support at first sight. You might say, hey, if I use Kubeflow in my company, there will never be someone to support me, and we will get to that very soon. In terms of tools, I highlighted 4 of the most famous ones. I'm not sure if they're the most famous ones, but are the ones that I had in mind, and Maciek also mentioned or recommended through his discussion. So Charm Kubeflow, for those who are, or Kubeflow for those who are not familiar with it, it's an MLOps platform to develop and deploy machine learning models and automate workflows. The heart of Charm Kubeflow is Kubeflow pipeline, sorry, that Maciek already told you about. And if you're curious to see more about Kubeflow, just go on their website or look on the internet, because we have plenty of podcasts and webinars on that topic. Then we have MLflow, which I think is the tool of the community. It benefits from a wide adoption. It's loved by everyone. Last year they counted, I think, 10 million users, and it's primarily used for experiment tracking and model registry. It does have an important role. Then we do have Charmed or Spark, and last but not least, open source with its vector capabilities, vector database capabilities. I'm not sure, Maciek, is there any other tool that you would like to add in my recommended ones? I didn't include here Kubernetes, which probably I should have.
Yeah, I think that the whole underlying infrastructure story is super important there, because the optimizations that people do in upstream projects like Kubernetes, different schedulers, and GPU handling are super important, because there you can get even up to 6 or 7% of gain in terms of like output from a certain infrastructure, which is both important business-wise, environmentally, but also due to the fact that the access to GPUs is really limited. I mean, NVIDIA is doing great, but basically they cannot manufacture as much as the market wants. There are some other vendors that are trying to enter that space, but they are not near as popular or have good enough tooling to actually be used in production use cases most times. So basically there is a shortage of hardware, and we need to squeeze as much as we can from existing one. And I think that all of those infra things that the teams in the Kubernetes community or kernel teams in Linux distributions are doing is really great work, which is very underappreciated, because people just look at the UI of ChatGPT and don't know what's behind.
So I think maybe it's a good occasion to also highlight a couple of capabilities. I mean, I think running serverless using a tool such as Volcano integrated with Kubernetes are two of the important capabilities. Patrick, would you have any other in mind from the top of your head?
Like for the serverless perspective, the most important things for us would be Knative and the stuff that we are doing there, because you can very quickly also expand what you are doing into from on-prem environment to a public cloud, into a hybrid scenario. This works really well when you have some Knative implementations to work with AWS Lambda or Azure Functions. So I think that that's also an important highlight to make.
Thank you. And I will go towards how to use large language models with Canonical, and it's really it's almost equal to how to use LLMs with open source. And in Canonical, we have an MLOps solution that is a plug-in, plug-out architecture depending on the use case. That can be used actually to fine-tune your models and to benefit from a simplified deployment. We do have our own distributions. So we have Charmed Kubeflow, Charmed MLflow, Charmed Spark, and they benefit from security updates, which are very important and was one of the big concerns that organizations have. But also, they actually get enterprise support or optionally managed services. Timely fixes or capabilities such as observability or simplified upgrades are also part of the features that we have, and could help our users or help organizations get started with LLMs and then scale. And this is our last slide. I'm being conscious of time. We are in the middle of Canonical AI Roadshow. We go around the world and tell people, organizations, how they could innovate at speed with open source AI, from Chicago to Dubai, from Netherlands to Sao Paulo. You can meet us at any of the events. So if you pass by KubeCon, GITEX, MLOps, they're just some of the examples where you can find us, and you can see some cool demos from Maciek. Now I'm giving insights, but we really have prepared nice models that actually use LLMs with open source tools. Thank you for joining us.
And I think that also if you are on any of those events, we can have a chat about interesting things happening right now. So there is a question that I like to ask for people who are looking into like AI security, because for example, a couple of days ago, we had a huge set of vulnerabilities in PyTorch, one of the most popular frameworks, right? So it's even got a name, ShellTorch. It's CV score 9899, depending on who is scoring it. And the question that you need to answer yourself, who is CV patching your PyTorch with SLA? And if you don't know the answer, come and meet us.
Thank you, Maciek. And thank you everyone for joining us. Bye-bye.